Hi, this is Vader, and in this video, I'm going to be going over my machine learning projects I created for my MYP personal project. I'm going to be discussing the two projects which I believe held the most significance. Now, these projects were my waste classification and Safari image recognition projects. In front of you are the tools I used to complete these projects. I chose to use the Python programming language, and I used Anaconda to manage all the libraries and extra frameworks I had to implement. Now, some libraries that I used were Pandas, NumPy, and TensorFlow. Pandas was used to manage data, NumPy was used for linear algebra, and TensorFlow was for building deep neural networks. Kaggle and Toward its data science were also useful tools as they provided me with data and any theoretical information I required. Now that the prerequisite information has been gone over, I will dive deep into the details of both of these projects. I'm going to start with my Safari image recognition project. I could have collected data for this project by simply going to the Safari 10 website and downloading the entire dataset. However, due to the tools that I am using, I had a better approach. TensorFlow actually has the Safari 10 dataset built into its framework, so all it takes is a line of code to obtain all the data and the labels for training as well as testing. The Safari 10 dataset has 50,000 training images and 10,000 testing images, which makes it an absolutely amazing dataset to work with. Furthermore, all the training images are given classes such as airplane, car, bird, cat, deer, dog, frog, horse, ship, and truck. So it's clear that this dataset does not have any particular focus. However, it's great for learning purposes, which is indeed the focus of my MYP personal project. After data collection was complete, the next step was to create a machine learning model which was capable of making predictions. The model I chose to focus on was a convolutional neural network, or a CNN for short. I will not be going in depth on how CNNs function in this video as they are fairly complex. However, I'll be going over a general description of what they are. CNNs can be used for image recognition, image classification, and object detection, which makes them perfect for my task at hand. Each input image passes through a series of convolutional layers with filters that are also known as kernels. It then goes to the pooling layer, which essentially reduces the dimensionality and size of the image. This process repeats X amount of times. After the feature learning is done, the image will get flattened, meaning it will go from a matrix, two-dimensional, to a vector, which only has one dimension. Then it will go through a series of fully connected layers, and finally, the softmax function will be applied that has the ability to classify images with probability. Alright, so now I'm going to be sharing my screen on my VS Code editor and showing you my notebook or code of creating my neural network and getting predictions. So again, I am currently starting by loading the data from TensorFlow, and as stated before, it's very simple as it's built into the library. Here I'm essentially just changing the images from going up from 0 to 255 to 0 to 1. Here I'm giving a map of class names, and I'm mapping one of the training images to class names just for testing and showing how the class names will actually work. Here we display data on a 5 by 5 grid just to show the images and their mapping labels. As you can see, we have a frog, a truck, a deer, car, a bird, horse, things like that. Okay, and now I'm essentially just displaying the shape and size of the training images and the testing images. And now, essentially, the first number displays how many images there are, so 50,000, and this represents the width of the images and the height of the images, or vice versa, as they're squares, so it won't really matter. So they're 32 by 32 images, and the 3 is there because it's RGB color, so there's 3 values, one for red, one for green, one for blue. And the same thing is done here for testing images. Here I'm actually creating the neural network, and as said before, it starts with convolution, then we have pooling. We're repeating this 2 times and ending with a convolution, and then we flatten it, and then again we have a feed forward layer, and we end with a dense layer instead of softmax. The softmax doesn't really increase functionality, but it is good to do. However, it's not done in this scenario, but it still is fully functional. Here I'm compiling the model with an optimizer and typing accuracy in metrics. So while I'm training, I'll actually be able to see the accuracy increase, hopefully, or as it did not decrease as this model actually did work. So here we train the model, and I'm fitting it with my training images and my training labels. So the images are, as stated before, just the images, and the labels tells the computer what each image is. So it will learn what a cat looks like, a dog looks like, things like that. Epochs is essentially representing our batch training size. So we're going to do it tenths, and we're going to split into tenths, fairly self-explanatory. And our validation data set will actually test our images while training. So as you can see here, we have 10 epochs, and as we can see, our accuracy is increasing and our loss is increasing. Loss essentially represents error. So our accuracy is fairly good, pretty good. And usually image classification won't have a crazy high accuracy because it's not that simple for computers to recognize images. So you're not going to get like in the high 90s most of the time. So this does make sense. Here I'm saving the model so I can use it for future use. And I'm here testing the neural network. So as we can see, we have a neat little graph here that actually shows our accuracy increasing over time and our validation accuracy also creaking. So we had some sort of hiccup here. However, our model did pick up and increase at the end. Here we're evaluating our model on every single testing images. And here I'm actually going to test images using the TensorFlow Safari dataset. I'm not getting images from the internet just now. So as you can see, we have an image and we from the test dataset and it's shipped. That's right. Here we have frog. Perfect. And now I'm actually going to be able to make a function that will test images from the internet. So here, what this function does is it essentially opens images from a JPEG file, then it resizes them, then it gets them into RGB data, and then we make a prediction in the last line. All right, so now this function, all it takes is the directory of the image I've saved from the internet. So here we have image one, and as we can see, it's a boat. And as you can see, it's ship. I'm currently displaying the image, however, I'm displaying it how the neural network sees it, and as stated before, it's 32 by 32. And now we have image 2, and as you can see, it's classified as frog. Image 3 is a car, and image 4 is a horse. And finally, image 5 got classified as a dog. So as you can see, the neural network actually functions very well. And my next steps for this would eventually be to deploy it. However, I do have a time constraint for my personal project, so I might not be able to do it in this scenario, but I will definitely do it in the future. So now I have gone over the process and details of my Safari image recognition project. I will now move on to waste classification. I collected data from my waste classification project on Kaggle.com. I had to download all the images and manually process them for training purposes. The goal of this project was to classify an image of waste as cardboard, glass, metal, paper, plastic, or simply trash. I chose to use the ResNet 50 architecture as well as some extra layers such as pooling, so a dense layer, and ending with a softmax layer. I will not be going into the details of how the ResNet 50 works because it is very complex. However, it's essentially a more complex convolutional neural network. Now I'm going to take you through a practical process of how I completed this project. Again, it starts at Kaggle.com and downloading the data. Kaggle.com was also a very useful resource for me to get inspiration and help for anything I needed, as Kaggle is also a forum. It's not only a place to collect data. As you can see, we have communities right over here. But anyways, I downloaded this data and then I could start my program. The first time I did all this, I processed the data successfully. This was all pretty smooth. However, I realized that my training process was very slow. My neural network would take an extremely long time to train off this data, and it was not even that much. So the reason for this was that I did not have my GPU enabled. In machine learning or deep learning, which is more specific, you want to enable GPUs as they allow for faster training, and I'll go into another video explaining this as it's not the focus of this specific video, but essentially I had to enable GPU for this program. So the way I did that was I went into my Anaconda Navigator and then I installed the GPU part of TensorFlow. Then this line shows that it works, so here I'm just testing to see if it actually recognizes my GPU, and it does. So after that, again, I'm going to process the data, and I end up with this data frame. So I have a directory of the image and then the label. Here I'm creating image data generators, which is used for training, and this is where I actually build a neural network. And as you can see, here we have the summary of it, and it's very extensive. It's a massive neural network. And here I'm going to compile it with metrics, a loss, and an optimizer. And here I am training it. And this line here, essentially what it does is that sometimes neural networks can end up in a local minimum or a local minimum error. So this can happen, and you can save time by doing something called an early stop. So what this does is it will check the loss or accuracy, whichever one you choose, and it's going to check that every patient. So again, 5. So it's going to check every 5 epochs. And if it sees that it's reached local optima, it will stop. So then it will save a bunch of time for the person who's training it. So again, here I'm making a test generator to evaluate my neural network, and here I'm actually testing it on training images. And as you can see, it does work really well. So now I'm going to load a model I've created from my previous session. As what happens with notebooks, as if you close them out, it will forget everything that is outputted. So you have to do it again. And that's what I had to do here. But here I'm actually creating a function similar to the previous image recognition for the Safari dataset. What this does is it will take an image, any image, it will resize it, get the pixel data, and then output a prediction. So all this function requires is a directory. So as you can see, test images bottle.jpg, it says plastic, paper, and then metal. So this does work very well. I actually took this project to the next level because I wanted to deploy this on a web app, and I did this with Flask. So Flask is essentially a web framework for Python, and it allows for you to make services. So what you can do is I made a mock web app over here, and what it does, it will call the Flask right over here, and it will output a prediction. So this actually does function very well, and as you can see, I have the same function here, and I actually load the model from my previous session that I trained in my notebook. So now I'm going to show this in action. So I'm going to go off to my mock web app, which is right over here. I'll just refresh it, and I'm going to choose a file. So bottle2.jpg, plastic, and we can go to the paper image, and as you can see, it does work. Now, I actually had a very big issue with this deployment process. And this issue was very minuscule, but it took me a long time to realize. What I was doing is because in my previous process, right over here, I was using JPEG images. However, when I deploy it, I actually specified PNG images, and I did not realize that until a long time of testing. So when I deploy it, I can only use PNG images. I can work on a feature to make it so that no matter what image you give me, I will convert it to a PNG and then make it to the Flask app and output a prediction. And we can see another image, metal. So this does work very well, and I'm actually going to take this even further because this only works on a local host. So it will only work on my computer, and my computer is not a server, so I can't leave it here and let the whole internet use it. So the way I do that is a Docker container, and then after I make a Docker container, I will put it on the cloud so that anyone can call the model. However, this process is still in production right now, and I am not complete this yet, but I have gotten this far with deploying it on a Flask app on localhost. So yes, this does work fairly well. And yes, that was my waste classification project. That concludes my machine learning applications for my MYP personal project. Thank you for listening.